Well, good afternoon, everybody. Thanks for joining us today. Certainly, I have a presentation to give on making the cloud real. Cloud is a inherently kind of can be a nebulous term, so we want to talk about really what it means. We'll walk through an actual case study of somebody who's integrated their application needs into public cloud environments and the lessons they learned. And actually the surprising lessons that they came out of it, things they thought would be difficult were not as difficult, and things they thought might have been easy turned out to be a little bit harder than they thought. But altogether, the business benefit that they were trying to achieve, they were able to achieve. So my name is Tim Connors, Director of Cloud Services for AT&T in the Business Solutions Group. And thanks again, like I said, for coming. We'll talk about key enterprise cloud features. When we talk about cloud services, not all clouds are created alike. Some have features that are important to enterprise businesses, and some have features that are more important for individuals or small businesses, and we'll talk about some of the differences. We'll go through our case study. That's the profile of the application that I'm here to talk to you about. I'll talk a little bit about AT&T's cloud service and how it was used by this customer and others. We'll talk about deployment choices, the different ways you can go about the cloud. We hear about public and private and hybrid and virtual private and all those things. We'll talk about those. We'll talk about the specific integration efforts that were done to make this particular application work, the results of it, and then, again, not all clouds are created equal. We'll hopefully give you some takeaways that when you look at cloud services, you'll be able to look at them with the same critical eye that certainly AT&T's customers bring to the table when they want to talk about it. Essentially, the standards are the number one things that drive cloud service. If we can't standardize a business process, we can't automate it, virtualize it, and then move it onto the cloud. So the more standardized that we are, and if we can build to standards that have been published and can be repeated, then we can get some of the benefits of cloud computing. So if we can work with templates of servers or storage or other compute images, that leads to the consistency that is needed to get a reliable service. But more importantly, it helps you get one of the other benefits of cloud computing, which is time to market. Because if you can take a template, make it your gold image, and bring it forward and repeat it over and over, you can be a lot more successful than having to build each individual one from scratch. The resources need to be dynamic and on demand, because if they're not, they're just traditional resources that we can't take advantage of the inherent nature of using what you need only when you need it, and literally without sacrificing performance or response times. I'll show some examples later of how our customer, the one who was working with us, was able to do this without sacrificing the performance. It's got to be full customer self-service, the ability to put an instance to sleep when you don't need it, to hibernate it, and then to bring it back, because if you lose it, it's gone. You can't have that environment. There's no point in paying for what you use if you have to keep something active at all times. That'll generate constant usage, and then you say, why didn't I just get a dedicated server? And then that also drives business velocity and agility, the ability to self-serve. You don't have to call somebody up to get new servers. You don't have to go through a procurement cycle. It's self-serve either through a portal or through an API to directly interact with the service. Those APIs need to be standardized, they need to be flexible, and they really need to be open. If the API is proprietary to whatever platform you're working on, the hidden consequences of using proprietary interfaces always come back to bite you when it's implementation time. It has to enable integration with existing apps, and also has to be flexible enough to let people innovate on top of it. If developers can't use cloud resources to innovate new applications, then they're not going to be adopted as readily. And finally, the pricing has to be consumption-based, back to what I was saying earlier before. If we're charging, say, a fixed monthly amount, we could call it a cloud service, but it's really not that dynamic nature, and pay only for what you use. So with all of these features, let's talk about the application and the people who came to us and said, can you help us with this? So they needed short-term capacity. The application is a development and test environment for an IT consulting operation. That's their system integrators. Their need was to be able to give their trainers, their people who train not only their staff but their customer staff on applications, easy access to server resources so that they could build the test and development environments behind them. They didn't want to get, again, into the lengthy procurement cycles. They didn't want to have to spend a lot of time building up servers only to tear them down when the training period was over. So they wanted the ability to get ready access to dynamic resources, easy to use, easy to get rid of when you're not using them anymore. They also had the requirement, though, that each and every one of the transactions that they gave had to be validated. The developers, the trainers needed to be authorized to consume these services, because if you're paying for what you use, you need to be able to at least track and manage usage. And furthermore, they wanted the ability to charge all the transactions, all the resources that they're consuming back to the individual projects to make sure that the resources weren't overused or overconsumed, and that they had legitimate tracking, fully allocated their costs back to the projects. The developers, excuse me, so the developers needed these servers. They could be generic Windows or Linux servers, nothing unique, and then they build upon them, but then they want to create that template and reuse it over and over, because the template would be what drives the efficiency. We don't want to pay developers or trainers to build servers. We want to have them available for them on demand. So these consultants who work on this can provision their short-term images, use them for 3 to 6 months, and then retire them and move on to the next project. So what they built was a cloud console, which was essentially a front end. And the front end gave easy access to the back end, which is the cloud infrastructure. So in that cloud console, that's where the authentication happens to say who the person is requesting the resources. They put in the specs, what type of resource they want, and then the cloud console goes out to cloud providers, finds that resource, and delivers it to them as an authorized user. It's easy, it's controlled, it's auditable, and fully billable back to the end customer, because remember, a system integrator consultant, every expense they incurred needs to be tracked and billed back to the project and ultimately to the end user. And in this case, it was a multi-provider solution, because they wanted to be able to optimize based on geography, based on performance characteristics, based perhaps on price, the budget of the underlying project that they're doing, or based on features. So this is a multi-provider cloud console. The service that we provided as the underlying piece to the cloud was our AT&T Synaptic Compute as a Service. This is a service that's based on the vCloud infrastructure, why I'm here today, to talk to you about it. And it's an enterprise-grade solution, has all those features that we talked about earlier that makes it really ready for enterprises. In addition, it has a multi-layer security model around it, so that the individual physical security, network security, and all the intrusion prevention, DDoS prevention, firewalls, all those services are built right in, so that the traffic that goes through the environment is scrubbed, malware is blocked, and other negative traffic that you don't want in the environment is kept out of the way. It's available with either public, internet-facing, or private. Any number of VPN, MPLS, or other private networking options can connect into it, and it's available again on a pay-per-use basis. The operating systems and software then operating systems are selected by the user, and then any software they need to load on it is just loaded directly onto it, whether that's an IT buyer, an app developer, or in this case, a trainer. And then through our AT&T portal, Business Direct, that's how our customers largely interact with the service. That's how they sign up for it, that's how they make changes to it, and that's how they authorize users. In addition, for a more granular level of reporting and control, we do expose an API to them. It's the same API that the portal calls, the same program calls that the portal provides. It's just an extra layer of control for a more automated or dynamic environment, much like our customer here chose to use. They don't go into the portal every time they want a new server, although they could. They actually interact through the API. And then we're building to make this a complete solution, a group of cloud enablers, and those are the developers, the software providers, the other solution providers who build services on top of a cloud service. So the folks here are going to be one of our cloud enablers when this application of theirs is ready for prime time. They want to actually deliver it out as a service to others in the business because they're so happy with how it's worked out for them. Back to the deployment choices, because it's important to cover some of this, whether we're talking about software, platform, or infrastructure as a service, whatever layer that is. The computing model that I talked about earlier is infrastructure as a service. There are a number of deployment choices that can be made. It can either be private cloud, single tenant, dedicated infrastructure. It can be on a customer premise or hosted with an external provider. But the key there is it's managed by one organization for the benefit of that organization, and it's generally that organization being the only tenant. On the other side of the spectrum is the public cloud solution, where it's internet-based, massive multi-tenancy, put as many different tenants on an environment as you can. The provider's interest there, of course, is scale, getting as much usage on the platform as possible. But sometimes the reliability is more on a best effort basis than on high enterprise grade SLAs, because the provider doesn't control the network. The provider sometimes hasn't thought through all the need for security. We've seen instances of public clouds be the foundation for DDoS attacks, not only on that cloud environment, but on others, and some other things that really aren't thought through all the way by folks who put up some of these services. And then there's that middle ground, virtual private cloud, and that's the one that you see a lot of the network companies like AT&T developing, where it's more of a hybrid model. It's the ability to have private cloud for applications that require it, either because of their performance or security characteristics or the compliance needs, or the fact that they just maybe won't run on a virtualized infrastructure, combined with some public resources, but delivered not in that best effort basis, but through a private or VPN connectivity option that's fully controlled, that has SLAs and quality of service on it, and that's delivered by a network provider as opposed to just bringing it in over the public internet. So the separation is based on trust. So when you're coming in through the VPN or you're coming in through the other private network, the provider knows that it's a trusted connection, and it eases a lot of the complexity associated with bringing traffic in over the front end or the public internet. So that's the security and performance of the private cloud, but with the economics and flexibility of the public cloud. And that's the environment that this particular customer of ours used to build this solution. I'm going to show some diagrams here of the application and some of the flows. However, I'm not a programmer. I didn't do the work, so I won't have answers to questions about, what was the underlying code, say, that was done. Anybody with interest in that can see me afterward, and we'll get you in touch with the folks who did it. I just won't be talking about that here. But they started out, this customer, with a cloud console. It's a front end. It's built in Adobe Flex, and it has an API. It's a Python-based backend that cloud providers could be added with minimal to no rewrite of the environment. Their goal was to be able to, they started with other cloud. That's one of the other providers besides AT&T. And they built this single instance cloud console, and their developers were using it. Their consultants were using it. They were able to call up the resources as needed. But the goal was to say, you know what? I want to be able to add more cloud providers to that. I want to be able to get additional networking options. I want additional features, because some of my apps will have a requirement to run in a different environment. They can't all run in the same one. So I want to be able to take that cloud console without a lot of rewrite and add additional providers to it. That was really the goal of the effort when they came to work with us. So the console front end goes to the console back end. The language wrapper goes around it, and it interacts directly with the API put out by that other cloud provider. Fairly straightforward model. The results, when they added the second instance, which was our Synaptic Compute, it exposed a flaw in the customer API. So when I talked earlier about how the things they thought would be difficult turned out to be easy, and the things they thought would be easy turned out to be a little bit hard. They thought integrating to the cloud API would be hard, and that modifying theirs would be easy. Turned out to be the opposite. They'd hard-coded some things in unintentionally that only worked with one cloud provider. They found it, the things didn't work, so they were able to modify it. And once they did that, the front end of their cloud console didn't require any more changes. So once they were able to talk to the cloud, a second environment, the Synaptic environment, they didn't have to make any more changes to enable full self-service. So imagine that, a few hours perhaps of coding, testing, developing, and rolling out, and all of a sudden they had a second provider underneath it. The difference is they have this mix-in wrapper there. That's the piece of software that they introduced in the middle that manages the multiple clouds. And that on the back end now they have the Python language wrapper to go to the other cloud, and then the language wrapper that goes to the AT&T Synaptic cloud. So again, every time now that they added a cloud provider, all they'd need to do is modify and come up with another simple wrapper to go against that provider's API. So anything to do with instantiating a server, getting more storage, changing the characteristics of a server to give it more virtual resources, all can be done through the API calls. Nobody needs to log onto a portal again. Nobody needs to place a call to their provider or a change order or anything along those lines. Any questions so far on the things we've talked about here? Any comments? I want to be as interactive as we can. It doesn't have to all wait till the end. Anybody had similar experiences trying to do this yet? Okay, good. So when we talk about cloud computing and the way AT&T approaches it and goes to market, we're really talking about taking things like performance. When this customer brought their application onto our cloud, they actually saw an improvement in performance. The servers loaded faster. The changes that they made got applied faster. Again, taking advantage of the high bandwidth and low latency that the networking that's available provides. A globally consistent experience. Regardless of where the cloud infrastructure is located, it's got to be similar in performance, because otherwise you don't know what you're buying when you buy it. If you have multiple instances in multiple locations, you want them to have the same functionality, the same performance characteristics. And then in those areas where you don't have that high bandwidth, low latency environment because of the way networks are built around the world, you want the ability to add optimization or acceleration type services so that the network experience becomes the one that you're used to seeing when you do have the high bandwidth. The security has to be in there. The integrated multi-layer security model that I talked about earlier, of thinking about security from the ground up, not as an afterthought, but as an underpinning of the service, needs to be there. Intrusion detection and prevention, network resident DDoS protection. And furthermore, reliability. If the networks, the data centers, and the individual architectures aren't built to full redundancy and the ability to scale, if the data centers aren't highly available, if the operations and support team doesn't have experience in these types of environments, then of course you run the risk of not getting all the benefits out of the cloud that you thought you would. And finally, control. The ability to go with a diverse networking choice, whether it's MPLS, VPN, internet. The APIs have to be open and flexible in order to make them work to the best of their ability. And then the ability to take those transactions and bill them out to departments, either as a direct chargeback or through allocation or in any other way. The granular enterprise billing options, or the ability to serve small businesses with more aggregate bills that don't have all the detail. Both of those are important in looking at a cloud provider so that you know that you're getting the same experience that you get from other enterprise class IT providers. Any questions or comments from the audience? Yes, sir. Is this global? Right now, it's in the domestic U.S. We will be in Europe in early 2011, and then we'll be in Asia, hopefully late 2011. We started out in the domestic U.S. because that's where we're based and the majority of our customers as well. Sure. So the question was, are there guarantees on the bandwidth, any latency or SLAs? And the answer is absolutely. So the different MPLS service options each have their own unique SLA associated with them. So they're all based on what type of traffic you're bringing it over it and which class of service you put, say, your computing traffic in or your cloud traffic in. But there are SLAs on, I can't quote them to you today, but they're on the AT&T website associated with each individual service. Some people go for a very high grade service, and others opt for a lower quality service and make the trade-offs there. So there isn't like a blanket SLA, but each service has an SLA associated with it. Yes, sir, in the back. I didn't hear you, so I'm going to come back and try and get the... I'm getting there. Sorry. Data center migrations, absolutely. We do that. Our cloud service really grew out of our hosting business. Okay. Right. Right. Yeah, we have a network integration team that really covers the globe in doing things just like that. Any type of transition, migration. Sometimes it involves upgrades or physical moves. Sometimes it involves transition from one platform to the other. But there is actually quite a broad portfolio of folks. Anything from moving trucks to move equipment to just physically or logically moving the data from one place to the other. Yes.
Did you say you built this on top of the app?
Yes.
And what were you able to use out of the box? What extra stuff did you implement yourself to get the solution?
Sure. So out of the box, we have the entire VMware stack. I don't know all the individual details. My engineer that built it isn't here with me. But we didn't add things to make the VMware software stack work. We got it working outside of the box. What we added on top of it are the control mechanisms that interact with the rest of the environment, because the server stack is the VMware, but then we have the firewalls, the load balancing switches, the layer 2, the layer 3, and the DDoS and whatever. So we've built our own program around it that runs on a Java platform. So that's really the API that our portal interacts with. It's kind of the control API. And then that calls the vCloud to do all the VMware things. But it also calls the functions inherent in all the other pieces, the infrastructure, storage, the whole package. Sure. One of the primary ones is around the development and test, right? So that's almost a given because of the seasonality of it. Meaning not that it's tied to the calendar, but that it's short-term usage. We've seen a lot of popular workload options around archival data. We've seen people use these cloud servers as like NAS front ends because they want a sort of a beachhead in a data center where the storage is, and they're building a front end there. A number of the things that make cloud storage look more like NAS run in VMs now, if you look into that environment. And then the other popular one is just general purpose collaboration type, a wiki or a SharePoint site or something that's important to the company. They want their employees to be able to do this, but it's not mission critical. They don't build out a dedicated, say, SharePoint environment. They'll do it more in a cloud environment. Those are some of the early adopters. That's what we've seen very popular. Yes.
In your physical build-out, you've done the bladed architecture?
Yeah, we actually right now have it running on a bladed architecture. I care to have a discussion afterward. It's somebody you've heard of. It's not like white box or custom, it's commercial stuff. But over time, we see them, it's not going to be like a locked-in solution. It'll always be, every time you build out a new pod, you look at what's the optimal mix, because we're virtualizing it, and therefore it's not as critical. Yes, sir. Absolutely, because that's really the key to anybody moving the workload onto the cloud. What do I do? When am I ready? Which apps are ready? Yeah, so that's something that our consulting firm is very strong in. Yes, sir.
Is the multi-layer security infrastructure based on the VMware feature?
It augments it. So the virtualized server environment is covered by that. But in addition, we have AT&T's DDoS protection on top of it, because that sits in the same data centers where this sits. So all the traffic that comes through there is scrubbed through that. And then the additional, traditional firewalls and intrusion prevention and other things are more the traditional ones you'd see in, say, a hosted environment. Exactly. So everything that extends beyond the realm of the VM world, we've added to make it a complete solution, because you need all the other components, not just the servers, but for a compute environment. Yes?
What kind of changes did you have to make to your infrastructure to move from like hosted to physical thing to virtual? Was it a drastic thing that you had to do?
So the question is,
Was more directed towards like changes?
Yep, so the question is, what kind of changes did we have to make to the infrastructure to go to a virtualized? And the answer is the changes were made over time, because we've been virtualizing networks and virtualizing servers for 4 or 5 years now. What we didn't have before, and what makes this service unique, are the API access and the business model of pay-as-you-go. So we've had virtualized hosting solutions for more like a fixed monthly rate. We have a Synaptic hosting service, which is a managed hosting, pay-as-you-go, pay-as-you-grow, but not by the hour. It's a very flexible service, but not as granular as the cloud service. So the real change was in the BSS, OSS systems to be able to bill per hour, per CPU, per gigabyte, rather than per month. And the other change was in the control mechanism that enables us to provision for customers, on demand. Those were the real.
Hardware to accommodate the new billing and management.
Yeah, not really new hardware, but some new software to write on top.
Hardware was good enough.
Yeah.
Including the networks and everything.
Right. Yeah, because the networks we'd already built multi-tenant virtualized networks and put dedicated customer servers behind them. So to take that same infrastructure and put a multi-tenant virtual server farm behind it wasn't as big of a jump. And even that multi-tenant virtual server farm is one we'd used in our managed hosting business before. The key here again is that it's now, instead of all managed through the operating system or application by AT&T, we're managing only up through the hypervisor layer and giving customers full control of the servers that run on top of it. Yes?
Would you care to comment on the sweet spot as chunks or physical build out, like 2 socket 6 core?
I can't, because I don't have that knowledge myself. But when we have our chat afterward, we'll get your contact information, and we'll get the people who did it, because it's a very important choice. Yeah. Oh, good.
What happens when your customer's needs grow beyond the size chunk that you have? Philosophy.
Well, when the customer's needs grow beyond what we can provide to them, we would, on a excuse me. So just, do you mean when their need for a single server exceeds, say, 4 by 16 by whatever? that would be a discussion then, hopefully in advance, we'd say, so when you get there, because when we're doing the design, it's usually like, well, here's what it will look like virtualized, and here's what it might look like physical, dedicated, and then there's the trade-off. Generally, we see that the things that need to scale all the way up vertically that way tend to start off more on dedicated environments, like an Exchange, an OLTP, a database. We try not to put them virtualized in the beginning for several reasons. Manageability, performance are a number of them. But things like web servers, app servers, other things that scale out nicely, you can grow out. So we don't say that you've exceeded it. You know, create another virtual IP and you're on your way. You've scaled out that way. Yes.
You mentioned standardization in templates.
Yes.
You also mentioned hybrid or model moving from hosted services to cloud services.
Yes.
Do you can you see any problems of scale or just keeping those templates in sync? Is there any solutions that either from the customer or you that you guys are looking at how to understand?
Yeah, so that's a fantastic question, and what we've seen to this point is the customers essentially building that themselves, we're hardly ever at the beginning of any project because they're always ongoing. So their manageability, their management infrastructure and processes and discipline are already well established. So putting kind of our stuff in as a complement to what they're doing already, they're pulling our stuff in and managing it the way they always have. Not necessarily, and the way they always have isn't always the best, right? But it's sort of the what they know. I think that the commercial tools market has a great opportunity to get on top of that. Haven't really seen it yet to be outside of, say, the management stack of an individual product, like, you know, managing server, software, vendor, XYZ's stuff with their tool, great. When you want to go cross-platform, that's where the opportunity lies. Yes?
Can you comment on how much you see people doing hybrid cloud as moving existing workload from your private data center to a public cloud versus people actually creating brand new workload, which is more popular? What do you see some of the obstacles in each?
Sure. So I'd say most popular today in practice is creating new or fully moving a workload into the cloud. So it's essentially a new instantiation of the existing workload, and that's because of what some of the challenges are. The challenge of the hybrid model are around the manageability and the predictability. They're overcoming them by relooking at what tools and processes they're using to manage and saying, what do we need to get out of this? Why are we doing this? If we're doing it to get flexibility, to save time, which can equal money, and to be able to grow according to how our business, have our IT grow with our business and not in advance of our business, right? So it's the old, why are we virtualizing in the first place? Why are we going to an external provider? I want the network performance, I want the scalability, I want the cost savings. So when you factor all those things in, the workloads that bridge that private to public gap, divide, it's not a gap, it's a divide between them right now. Those are the things that the customers are looking at and saying, which ones can I allow to grow that way versus which do I have to keep sort of close to my vest inside the enterprise? Yes, sir. Yes.
What are some of the barriers to entry or harder sell in terms of getting people to buy into this idea of moving to the public cloud?
So the hard sell, what are the objections that we hear the most for people that say they don't want to move into the public cloud? Interestingly, one of the ones that sort of rolls right off people's tongue is they always say, well, security, right? So security. We're finding that the customers who have mature, documented, disciplined risk mitigation for their existing information are comfortable having that information reside outside of their four walls. We're finding that the ones who have always managed to be secure by building the moat and putting the dragons in it are afraid of having it breached. But I think it's because they don't really have that full grasp of what risks they have today. A very large multinational firm, we had a great discussion. We left with differing points of view. If it leaves their walls, they say it's inherently not secure. If it's inside their walls, they say it inherently is. And I said, so the threats from within don't bother you? I said it in a little bit more polite way than that, but that was the gist of it. And I kind of got a funny look. And hopefully they went back and re-looked at how they're doing things and realized that there are threats from within and without. But the ones who have cataloged their applications, assigned a risk profile to them based on the information contained therein and what would happen if it was breached, because eventually it probably will be at some layer, some way, shape, or form. Some of that information is going to get into not the wrong hands, but not always the right hands. What do we do about it? How do we follow up on it? And how do we take action? How do we report on it? And how do we show through audit, through compliance reporting, that we've taken the necessary steps and have the controls in place? Those folks, I'm working with a customer advisory group now, and it was a real eye-opener to me to hear their comments exactly there. We're not afraid of that. So then I slyly say, so the security people worry about is job security, right? That's the one that they're concerned with. But the cloud doesn't put anybody out of a job. It's another way of doing business. It's another way of giving IT the flexibility to support the business the way the business wants to be supported. And frankly, buying it this way, with the control, with the choices of provider, with the authorization to say, yes, employee A, you're authorized to consume these resources. Employee B, based on your role, you're not. All of a sudden, they don't have people kind of going off the reservation, swiping their credit card at the cloud machine, and getting servers, putting company information out there on assets that they don't control or have any visibility into. Yes, sir. Yes. Right. Right.
Whatever we need to do to get PCI compliance. So do I have to do additional stuff if I want to put my stuff on your cloud?
Well, the answer is any change of platform always requires that extra level of due diligence. The folks who do PCI have sort of to this point said the cloud is inherently insecure. Therefore, it can't be PCI compliant. So you say, okay, well, tell me why. And generally, it comes down to multi-tenancy. But there are multi-tenant solutions that are PCI compliant. They exist today. We sell them in our Synaptic hosting portfolio, where it's managed by us. So it's a learning and an education process of the folks who do it. And it's going to be driven largely by the constituent members, the ones who handle the most transactions, the ones who have the highest volume of risk on PCI, are going to be the ones who bring the regulators along and show them it's really going to be okay because we've got these extra levels of control and reporting. I think that getting through that kind of first audit will be a big landmark for it.
That's not there yet.
Right. So you can't go to Visa's website and get a check mark next to anybody that says they're infrastructure as a service is PCI compliant, the way you can with some managed services. But the work is ongoing to make sure that that can be done. And that would be, when you can't get that checkbox next to the provider name, that does shift some of the burden back on you to cover any.
So cloud as a check technology, if you put it in private, would you still be PCI compliant?
Private cloud generally can get that a lot faster. Because that multi-tenancy thing's off the table. Now, that's a well-managed private cloud, right? Because a poorly managed anything won't be compliant.
What I was trying to get at is that you have a regular infrastructure, the physical
Mhm.
infrastructure, and your PCI compliant.
Right.
So then you move to say cloud kind of thing.
Like 17 of the 237 options, you now don't have to validate yourself. It's like incrementally, the extra layers of control and security for the different levels of PCI just keep adding up. So I mean, one of the interesting thing is when we do accept for smaller businesses and for individuals, we'll accept their credit cards on a PCI compliant website, but they're not buying a PCI compliant service with it. So it's ironic. Yes?
So earlier you mentioned that phase workload is more popular today than workload data center, right?
Right.
But for those customers that have actually done that, what do we see has been their acceptance of the amount of time it takes to do a workload and data set that comes with it to the cloud? Like, are they expecting like minutes? If they say, oh, this is going to take hours, like how do you look? Like how do you deal with that kind of question?
So, yeah, and we address it by asking them in the first place what they're trying to accomplish, right? So what are your expectations in terms of, say, when the cloud would pick up the workload, for example, or hand it back? And then they say, well, we've never distributed this application across locations before. So then we take a step back and say, okay, so what's the wide area networking look like in between there? Have you optimized that? Have you made things ready to do the types of things you're trying to do? Because there isn't a magic switch, right? It's good old-fashioned engineering to make that kind of stuff happen. But if they're on a optimized network, then we'll run a proof of concept with them very often. Because one of the other parts about the cloud service with the pay-as-you-go and relatively minimum commitment that they make is they can try it. They're not going to do the full-blown integration of software in their management stack like we talked about earlier to make it all work, but they'll have people at a command line and watching it to see if it plays out and performs the way they want to. Well, sure, to a point, right, within budget.
Right. So it sounds like that's something that if money can solve the problem, if you're like this is really urgent for us to do about
Well, yeah, I mean, there's a point of diminishing return. One of the reasons we're investing in making that MPLS VPN fabric cloud aware is because then they don't have to invest additionally in the network. They're already buying that service from us. So our investment is to make our cloud infrastructure endpoints on those networks, and then they can just change the class of service to get the level of performance that they're looking for. So we're not running new pipes into their places. Because thank you. I couldn't have said it better myself. Any other questions? Comments? Please make sure to complete the survey online. We've done away with the paper surveys this year, but folks have asked that we create the surveys online. It's on the mobile website as well as the regular website. And certainly I'll be around here for any follow-up questions or comments. You can find me on Twitter, you can find me on LinkedIn, and I look forward to further discussions with the team. Thank you.